For this slide, there are several types of airborne chemicals. These include dust, respirable dust, fume, fiber, mist, gas, and vapor. Dust is solid particles. For example, in construction work, respirable dust is very fine dust that can enter lungs, commonly found in mining. Fumes come from heated metals like in welding. Fiber refers to thread-like particles, such as in textiles or asbestos work. Mist is tiny liquid droplets often found in spraying activities. Gas is invisible substance like carbon monoxide in factories. Vapors come from evaporated liquids, for example solvent in painting. For our selected airborne chemical is airborne metal fumes. For monitoring, we use NMAM7082 method. This method is used to measure respirable particles, especially lead particles. It is suitable for activities like soldering using lead-based materials. It also helps to assess workers' exposure to hazardous lead fumes.
The equipment used for this monitoring includes an air sampling pump, a flexible connecting tube, an MCA filter cases, a calibration device, or a revised plug when required. So inside the cassette there is an MCA filter paper which acts as the main collection medium where airborne lead fumes are trapped on its surface. So the air sampling pump is used to draw air through the system at a controlled flow rate, while the connecting tube links to the pump to the cassettes. The calibration device is used to make sure the flow of the pump is accurate before and after sampling. So each cassette has two sides, which are the inlet and outlet. So the inlet is where air enters the cassettes and the outlet is connected to the pump using the connecting tube so that air can be pulled through the filter. So before sampling, we prepare a total of 6 cassettes. One cassette is used for calibration, 3 cassettes are used for actual sampling, and the 2 other cassettes are used as blank samples. Next, pre-calibration is carried out. So the inlet of calibration cassettes is connected to the calibration device, while the outlet is connected to the air sampling pump. So the pump is then switched on and adjusts until the flow rate is about 1.0 liter per minute. And after calibration, the pump is turned off and the calibration cassette is removed. So a new cassette is then attached for actual sampling. So during calibration, the cassette is placed at the worker breathing zone. So the inlet faces the air and the outlet is connected to the pump. So the pump is switched on and air is drawn through the cassettes while soldering work is being carried out. So the airborne lead fumes are collected on the filter paper inside the cassette. So at the same time, blank samples are also brought to the sampling location, but the blank cassettes are not open and not connected to the pump. So they are not exposed to the air. They are used as control samples to check if there is any contaminated during handling, transport or storage, so that the result from the actual samples are accurate. So after the sampling period, the pump is turned off and the sampling cases is removed carefully and sealed. Then post-calibration is carried out using the calibration device to ensure the flow rate remains within the acceptable range after sampling. So finally, all cassettes including both samples and blank are labeled properly and sent to the laboratory for analysis.
Chemical exposure monitoring, or known as CEM, is a process used to assess workers' exposure to hazardous airborne chemicals in the workplace. In this case, CEM is applied to evaluate exposure to lead fumes during soldering activities. This is important to make sure the exposure levels remain within the occupational limits and does not affect workers' health. In conclusion, each airborne chemicals have different characteristics depend on work activities. For metal fumes like lead from soldering, proper monitoring is important to protect workers. The NIOSH and MAM7082 methods, together with proper sampling and CEM, helps ensure the exposure stays within the safe limit.